Hello guys, how you doing? This is the second session of chapter 2 of Fluid Mechanics 1, and I hope you follow me with this session in order to acquire the knowledge of this section. Follow me with the video. So, the subject of this session is basic equation for pressure field. My name is Amirreza Talaqat and my email address is amirrezatalaqat@gmail.com. I'll be delighted to answer all of your emails. It might take several days or several minutes, but I try to take an action as soon as possible. So, the principles of this section is to identify how we can measure the variation of the pressure from point to point, as long as it is going to generate a pressure field. You know, guys, when we have a mass within a fluid and it wants to it wants to be replaced from a point to another, there are two forces exerted on the fluid. You might remember the last session, as I told you, but we are going to verify it in detail in this session. The forces are due to surface as well as body, which pressure is due to the surface and the weight is to the body. There might be some other possible body forces, such as magnetic fields or any other forces. So, in order to verify the pressure field, we have to use basics of finite elements, which is we consider a cubic of fluid which has a pressure, which has a point, and we're going to verify the pressures are exerted on this point. So, in this section, if we have a pressure, as we go forward, the pressure is going to decrease by delta P over delta Y, delta Y over delta 2, multiplied by delta X, delta Z. Delta X, delta Z is the area of this section. Let me illustrate this section in this picture. If we have a pressure here, when we go forward, the half of the way is gonna be exerted, is gonna be declined by the pressure. You know, when we go forward, as we go forward, the pressure is gonna decrease. And vice versa to that, if we go from this point to point here, if we, as I told you, if we go from here to here, the pressure is going to decrease. Since, let me verify it. How can I tell you? Because it seems like to be mixed up. Let's me illustrate it once again. If we have a point here, if we go to the left, if we go to this area, the pressure is going to decrease. And vice versa to that, if we go to the right side, it is going to increase. And also, if we go upward from this point, the pressure is going to decrease. If we come downward, the pressure is going to decrease. Excuse me, in this direction, it is going to increase. In this direction, it is going to decrease. So, applying Newton's second law, we have this equation. because P minus delta P over delta y over 2 multiplied by delta x delta z is here, when distracted by this equation. Doing the calculation, we have this equation, which is minus delta P over delta y, delta x, delta y, delta z. It is similar for other directions. And at the end, we have a deviation equation of force, which is delta F is equal to delta Fxi plus delta Fyj plus delta Fzk. So let me just tell you once more. When we have a point, there are two halves, which is in the forward or in the upward, and the left or downward. Downward and left are minus because we are getting back. Upward and going to right are positive signs of pressure. So we have already realized that pressure may vary across a fluid particle. So as you know from here, we are going to achieve first equation of this chapter, which is equation 2.1. And going through its details and verify it more, we are going to have equation 2.2. I'm going to illustrate the way of achieving equation 2.2 in the written text. Follow me with it. Welcome guys to this section of proving equation 2.2, chapter 2, section 2.2. As you know, in equation 2.1, we reached to this equation. Let me have it in my site. Yeah. Delta Fs is equal to minus round pi over x I hat plus round p over y, round y j hat plus round pi over z k hat multiplied by delta x, delta y, delta z. So this term is gonna describe as a gradient of P. So when we have a gradient according to mathematical concepts, it means x means round x over y over x, excuse me, I plus round x round y j plus round x over round z k. So we can identify delta S Fs divided by delta x, delta y, delta z equal to gradient of P. And also, as long as we have only the z direction in the vertical and it's downward, we have delta wk is equal to minus gamma delta x, delta y, delta z. And according to Newton's second law, sigma of delta F, excuse me, let me just verify it here, sigma of delta F is equal to delta M A, which means we have delta Fs minus delta Wk is equal to delta M A. Let me have it tidy. Yeah. If we derive them, we are gonna have gradient of P delta X delta Y delta Z minus gamma delta X delta Y delta Z. And also at the right side, we have rho delta X delta Y delta Z A. If we distract these terms, and let me just have k hat here, we're gonna have the gradient of P minus gamma k is equal to rho A, which is equation 2.2. Welcome back, guys. As you might have known, the equation 2.2 is is regarded as assumption of no shearing stress. This equation is also going to be utilized in section 2.12 in the upcoming sections. At that section, we're going to illustrate how the pressure distribution in a moving fluid is generated or gained. By now, we're going to restrict it out. So, we have already known that the pressure and the resultant force acting on a fluid element depends only the pressure gradient, which is here, if there is no shear stress. Pay attention to that. It might come to your exams either as a principal questions. So guys, this is the end of section 2 of chapter 2 of Fluid Mechanics 1. I hope you have acquired a good knowledge of verifying pressure field, basic equations of pressure field. And I'm very happy that you have followed the video till this moment. I'll be appreciated if you subscribe the channel in order to get the notification of upcoming videos. See you in the next sessions, and bid you all farewell.